In recent science news, Pluto has gained the spotlight, but there's another P in science that's just as fascinating: pentaquarks. What exactly are pentaquarks? To understand this, we need to look at the basics. Atoms, as you should know, are composed of three particles. Protons have a positive charge, neutrons are neutral, and electrons are negative. Of these, only the electron can't be broken down into smaller particles. Protons and neutrons are made up of tiny particles called quarks. Specifically, protons are made up of two up quarks and a down quark. Quarks, like electrons, cannot be divided into smaller particles, although this could change soon. Each quark has a symbol, and their opposite is read with that symbol and the word bar after it. A top quark, for example, is T. The opposite of a top quark would thus be top antiquarks, or T bar. Yes, kids, antiquarks are considered antimatter. Quarks never exist on their own, so we always discover them through other, larger particles which are made up of quarks themselves. These larger particles are called hadrons. Where have we heard that word before? Oh yeah, the Large Hadron Collider at CERN. Now, up until 2002, scientists have only observed two types of hadrons: baryons, which contain three quarks, and mesons, which contain a quark and an antiquark. But in 2002, scientists in Japan claimed to have discovered the pentaquark, which is a hadron made up of five quarks. And in 2015, this year, CERN confirmed it, although the Japanese experiment was slightly different. I'll explain the CERN experiment. My graphics are horrible, so bear with me here. Scientists took a baryon known as lambda b and watched as it decayed into three other particles: a J-psi meson, a proton, and a particle called a kaon. Lambda b is composed of three quarks: an up quark, a down quark, and one of any of the other quarks. J-psi is composed of a charm quark and an anti-charm quark. A proton, as I already said, is two ups and a down, and a kaon can be either U bar or D bar plus a strange quark. The missing quark here is the strange quark, which goes to the kaon, and the anti-quark joined to create it. Now we have an up and down quark left over, and these go to the proton. That leaves us with three missing particles: an up quark, a charm quark, and an anti-charm quark. There's obviously a missing state here, which is, you guessed it, a particle of five quarks. And specifically, these are two up quarks, a down quark, a charm quark, and an anti-charm quark. This is the pentaquark. Alright, what's the big deal? The point is, we are trying to unravel a mystery that's baffled people for millennia. What is at the essence of everything? The pentaquark will help us unravel what complex processes take place in the mysterious quantum world. It's showing us how little we know about the tiniest particles and the bonds that pull them together. We know next to nothing about this strange world of smallness where logic barely applies. Confused? You should be. As the great Niels Bohr once said, if quantum mechanics hasn't profoundly shocked you yet, you haven't understood it yet. Thanks for watching.